This is the resistor principle you thought you mastered back in junior high, but in reality, you only scratched the surface. If your physics teacher had explained it this way, you might not have struggled so hard back then. Let's start with a question that sounds simple but isn't. If a resistor's job is to turn valuable electrical energy into useless heat, why does almost every electronic device rely on it? To answer that, we first need to understand what resistance actually is. Electric current is essentially the directional movement of electrons through a conductor, but no conductor is perfectly smooth. Inside every material are countless lattice atoms, and as electrons move forward, they constantly collide and rub against these atoms. After repeated collisions, the atoms heat up and electrical energy is converted into heat energy. This phenomenon is what we call resistance. According to Ohm's law, current equals voltage divided by resistance. When the voltage remains constant, increasing the resistance reduces the current. This is exactly why resistors exist. They are electronic components designed to control current by deliberately introducing resistance into a circuit. The structure of a resistor is surprisingly simple. A resistive material is wound around an insulating ceramic rod, and the type and length of this material directly determine the resistance value. Metal leads are attached at both ends to connect it to the circuit, and everything is sealed inside a protective plastic or ceramic coating. While resistors come in many shapes and sizes, this basic structure remains largely the same. If resistors are used to control current, then why not just directly set the current value instead of adding resistors? The answer lies in real-world circuits. In a complex system, different components, such as sensors, amplifiers, and chips, each require different currents to operate safely and efficiently. Resistors allow a single power source to distribute the correct current to each component. Beyond that, resistors come in many specialized forms. Take the adjustable potentiometer, for example. Inside it is a resistive slide rail with two fixed terminals at each end and a movable middle contact controlled by a rotating knob. As the knob turns, the contact slides along the resistive track, changing how voltage is divided. This is exactly how a volume knob works. Then there are photoresistors, whose resistance decreases as light intensity increases. Their operation is based on the photoconductive effect of semiconductors. When light hits the material, photons transfer energy to electrons, freeing them to move and increasing conductivity. Combined with components like relays, photoresistors are widely used in systems such as automatic streetlights. There are also thermistors, which take advantage of how electron activity in semiconductor materials changes with temperature. As temperature rises, resistance drops. This makes thermistors ideal for temperature sensors and control systems. In short, these tiny components may seem insignificant, but resistors come in countless types, each serving a unique purpose. With enough creativity, circuit engineers can make them do far more than just waste energy. That's it for today. Did you see resistors a little differently this time?